What law do we use? Hooke's law.
Years.
We use Hooke's law of springs as our model for the restoring force of a spring. True or false? The solution curves in the phase plane are determined by the initial conditions. True.
I remember that.
If y of t is position, then dy dt is velocity. And d squared y over dt squared is acceleration.
How bad were our quizzes if we had to go back to the basics?
Yes, that's a really bad question.
If I put speed, which includes
Hey,
direction,
these kids are stupid.
Yeah, if you put speed, that's fine. Yeah. Okay, so we're starting chapter 2 today. So we're going to start talking about systems of differential equations. That's 2 equations instead of just 1, which is what we did in most of chapter 1. There's 4 sections of chapter 2, and after that, we're going to take test 1. Chapters 1 and 2. I know that that's coming up. Not this Friday, but the following. Test 1. We have one more quiz in between there. One more take-home quiz. Yeah, so quiz 2 is due today, so make sure you put that in your folder before you leave. Okay, in many real-world situations, you have more than one dependent variable that often interact with each other, and a classic example is the predator-prey model. We talked a little bit about predator-prey models earlier in chapter 1, but let's remember, if we let R of t denote prey, R for rabbits, F of t, predators, typically F is for foxes, typical predator-prey, fox and rabbits. So we're going to assume that R and F are both always non-negative and have negative numbers of rabbits and negative numbers of foxes. So one system of equations that might govern the changes in the 2 populations is given by R prime is 2R minus 1.2 RF, and F prime is negative F plus 0.9 RF. So we want to think about the effect of each term on the 2 populations. So first, let's think about what happens to each population in the absence of the other, right? So let's think about rabbits if there are no foxes, right? So then R prime would just be 2R, right? Because F is 0. There are no foxes. So what's the solution to that equation?
R squared.
No. We would have to solve by separation of variables, right? It might be clearer if I write this as dr dt.
Also do that as R dot, so always time.
Yes, you can also use R dot. R with a dot over it means dr dt. It's a derivative with respect to time. So if I were to solve this by separation of variables, I get R of t equals c e to the 2t. So what happens to the rabbit population over time here? If there are no foxes, it grows exponentially.
That's a good question.
So if no foxes, rabbits increase
That's a good question.
exponentially. Ask what?
Let's always looking to something. Is it just because it will always dealing with linear equations?
It's just separation of variables. I just didn't write out all the work.
No,
So-
but why does it always e to the something though? Is it-
Because you end up integrating both sides, and
You always get an ln usually. Because the
let's just do it. Let's just integrate. So
Anything that's different than that, you can't use separation of variables, basically.
well, let's say one of R.
well, sometimes you can, yeah. But this is the Malthusian model, right? This is when a population's growth rate is proportional to the size of the population. And when we solve it by separation of variables, it has e in it. It just solves x to an exponential. All right, let's see what happens to the fox population in the absence of rabbits. Any predictions?
Increases.
Decrease, because the foxes eat the rabbits, and there are no rabbits. Yeah.
They become herbivores.
Yeah. Yeah, they'll either die out or they'll evolve, right? But according to the model, f of t comes out to be c e to the negative t. Right? So foxes die out if no rabbits. Okay, so that's what the first terms tell us. We know the 2r tells us rabbits grow if foxes aren't there, and the negative f tells us that foxes decay if there are no rabbits. What about the RF? There's an RF term in both of those equations. What do you think that tells us about?
What do we call that? We call it the growth factor. What about the growth factor?
Interaction. Yeah. R times F is a way that we can model how often rabbits and foxes interact. And then we put a coefficient on it that tells us the importance of the interactions for each species. Yeah.
So if the 1.2 and the 0.9 is different, does that mean like foxes kill rabbits more often than you actually did?
No, it just means that the rabbit and fox interactions benefit the foxes, right? Because it's positive 0.9. It's bad for the rabbits, negative 1.2. It's worse for the rabbits than it is good for the foxes. Does that make sense? Because the 1.2 is bigger.
How do we determine that ratio?
That is typically determined experimentally in the field, right? We would observe how rabbits and foxes interact and how they are, how they influence each other. Yeah. How frequently they interact, and how that number of interactions they have affects their population size. Okay, so RF is what we call an interaction term. If the RF term is positive, it's going to be positive for foxes and negative for rabbits. Right? Because it's good for foxes to interact with rabbits, bad for rabbits to interact with foxes.
If it's greater than 0, is not if it's on which function it's on?
I'm talking about the RF term. Yeah. It's positive for the fox equation, negative for the rabbit equation. Yeah. Those coefficients, the 2, the negative 1.2, the negative 1, and the 0.9, those are all determined based on the specific species we're modeling, and scientists typically collect data and use that data to figure out what the coefficients are.
So those coefficients are arbitrary to us.
Pretty, okay, so this system that we're talking about, it's impossible to solve it analytically. It's not linear because the RF term makes it not linear. So it's impossible to come up with the formulas for R of t and F of t. We just can't do it. But for some initial conditions, there are simple solutions. So if R of 0 and F of 0 are both 0, if at time 0 there are no rabbits and no foxes, what do you predict is going to happen to their populations over time?
Stay the same.
Nothing. They're always just going to stay 0, right? So in this case, R of t is always 0, and F of t is always 0, right? You got to start with something in order for the model to create growth or decay. So if you start with no rabbits and no foxes, there will always be no rabbits and no foxes. This is an equilibrium solution, right? Because nothing's changing. Are there any other equilibrium solutions?
Probably.
Yeah. So to find equilibrium solutions, when we just had one equation, we took the function, the derivative equal to 0, right, and solve. Same thing here. We set r dot, or r prime, equal to 0, and f dot equal to 0. So we have 2r minus 1.2 rf, set that to 0, and negative f plus 0.9 rf get set equal to 0. Two equations, two unknowns, right? R and f, two equations, I've got two unknowns here. So I'm going to try to solve this. Unfortunately, it's not linear, so you can't use linear algebra to solve it, right? But I do have a nice thing happens in these equations that in this first one, there's an r in both terms that I could factor out. So I'm left with 2 minus 1.2 f. So then I get two solutions, r equals 0 and f equals 1.2 over 2.
That's,
Sorry, 2 over 1.2, and that is 5/3. And in this one, I can factor out an f. I get -1 plus 0.9 r equals 0, so I get f equals 0, and r equals 10/9. So I already knew about the r equals 0 and the f equals 0 equilibrium solutions from the previous question, right? But then I have these other equilibrium solutions that I just found. 5/3 foxes and 10/9 rabbits.
So what's the units?
Number of rabbits, number of foxes. I know it's weird because they don't come out as whole numbers.
So pretty much if you have like 1 or 2 foxes, and like,
So it's a
and,
rabbit with two
and,
heads.
and like 1 rabbit,
Right.
that's the equilibrium?
Yeah. Well, let's call it thousands of rabbits.
That makes more
Thousands
sense.
of
I
foxes.
think that
Sure.
makes much more sense.
Okay, let's do that.
Tell me that's
Yeah, so
what rabbit was the stands.
so this is a sustainable situation where the fox and rabbit populations are in balance, right? They're in balance. So the foxes eat the rabbits. There are enough rabbits to feed the foxes. There aren't too many foxes that they end up eating all the rabbits. They're in balance there. So remember, a solution to a system of differential equations, to a system, right, is two functions, r of t and f of t. So my solution here would be r of t is 10/9, f of t is 5/3. Right? That's my other equilibrium solution. All right, so
Is it RT? 5/3? Or?
I got r was 10/9, right?
Oh, I wrote them wrong there.
Okay. All right, so that's it for the lecture part of class. You have a lot of activities. There's a lot of things to discover in the activities. It's not just practice, so make sure you work all the way through it. Let me know if you have questions.